Hello everyone. In this class, I am going to derive an expression for potential at a point due to an electric dipole. Okay. See, dipole means it consisting of 2 points. Okay. So which are those? So minus q charge and plus q charge, and it is separated by a distance 2a. Okay. Dipole means, so see, dipole formula P is equal to q into Ta. Okay, it is a product of magnitude of either charge of the dipole and dipole length. Okay, dipole moment. See, keep it in mind, the dipole direction is always from minus q charge to the plus q charge. Okay, the dipole direction is always from minus q charge to the plus q charge, and net dipole value is 0. Okay, so the dipole moment represented by P. So this is the direction from minus q charge to the plus q charge. And what is the dipole length? Dipole length is 2a. If this is 2a means, so this is becomes a and this is also becomes a. Okay, so call this as point O. Okay, so I will consider a point P here. Okay, consider a point P. So let OP distance. So in the previous derivation also I have taken let OP is equal to R. Here also I will take let OP is equal to R. Okay, so now this direction, so this distance it will become R1, and this distance it will become R2. Okay, so and this one is the angle theta. Okay, so now I need to calculate the potential. Here we will get two potential. One is due to the minus q charge, another one is due to the plus q charge. Okay, so I know the potential expression. What is the potential expression? V is equal to 1 by 4 pi epsilon naught q by r. Okay, so here V1 becomes, so 1 divided by, so 4 pi epsilon naught q due to the plus q charge, q divided by, what is the r? This one is r1. Okay, call this as equation 1. So similarly for the charge minus q charge, so what it will become? So V2 is equal to 1 by 4 pi epsilon naught minus q divided by r2. Okay, call this as equation 2. See, from the principle of superposition principle, I need to add the potential. Okay, so by the principle of superposition principle, I need to add V is equal to V1 plus V2. So now, so call this as equation 3. Okay, so V becomes, so what is V1? 1 by 4 pi epsilon naught q divided by r1, so plus V2. V2 is, so I will write a minus sign here only, minus 1 by 4 pi epsilon naught q divided by r2. Okay, from these equations, so q by 4 pi epsilon naught is common. Okay, take it outside. So V is equal to q divided by, so 4 pi epsilon naught into 1 divided by r1 minus 1 divided by r2. Okay, so call this as equation 4. Now I need to identify what is the value of r1 as well as r2. Okay, for this one, so I will draw the perpendicular. Okay, so draw the perpendicular here. So call this point as M. So draw another perpendicular. So this point as N. Okay, so now in triangle, see O, so consider this point as A and this is B. Okay, so consider OAM. So consider the triangle OAM. Okay, so apply cos theta. So what is cos theta formula? So base divided by hypotenuse. Okay, so which one is base here? See here, carefully you need to observe. See, opposite to the theta we will get a perpendicular. Okay, so opposite to the theta we will get a perpendicular. Opposite to the perpendicular we will get a hypotenuse. This one is hypotenuse now. Okay, don't think it as base. So this one is hypotenuse. Okay, so remaining side it will become base. So now this one is base, this one is hypotenuse. Okay, so now what is the base now? So base is OM. So OM divided by hypotenuse is OA. Okay, hypotenuse is OA. So that is equal to OM divided by OA. See, OA can be written as A. Okay, A. So now cross multiply. So A cos theta becomes OM. So similarly here, if you find out, you will get ON also A cos theta. Okay. So now, see here, if you see the figure, see here, AP. So here AP can be written as OP minus ON. Okay. See, AP is corresponding to this length, right? See here, now it can be written as OP minus OM. Okay. See, AP can be written as OP minus OM. So that one is R1. So R1 becomes, let OP is equal to, so OP is equal to R minus OM. So that is equal to R minus OM means A cos theta. Okay, this one is R1 value. So similarly, so BP can be written as, see here, so BP corresponding to this point. Okay, BP, this BP length corresponding to this point. Now BP can be written as OP plus ON. Okay, so BP can be written as OP plus ON. So now OP plus ON, so that is R2 length, so that is equal to R minus ON, so that is equal to, sorry, plus R plus A cos theta. Okay, so now substitute this R1 and R2 in this equation. So we will get V is equal to Q divided by 4 pi epsilon naught 1 divided by R1 value is R minus A cos theta minus 1 divided by R plus A cos theta. Okay, so now see here, so V is equal to Q divided by 4 pi epsilon naught here. So take out LCM and cross multiply. What is the LCM? R minus A cos theta into R plus A cos theta. Okay, so now cross multiply 1 into R plus A cos theta, it will become R plus A cos theta minus of R minus A cos theta. Okay, so now V is equal to Q divided by 4 pi epsilon naught here. So plus R minus R will get cancelled. So minus into minus, it will become plus A cos theta. A cos theta and A cos theta, it will become 2A cos theta. Okay, so this is in the form of A plus B into A minus B. So this can be written as A square minus B square. Okay, so now V is equal to Q divided by, so 4 pi epsilon naught. So what is Q into 2A formula? So this one is P. Okay, so Q into 2A can be written as P. So P cos theta divided by R square minus A square cos square theta. Okay, see, for large distances here, for large distances, R is very much greater than A. So therefore A square cos square theta can be neglected. So we will get V is equal to P cos theta divided by 4 pi epsilon naught R square. This can also be written as V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. Okay, so this is the expression for potential at a point due to the electric dipole. Okay, thank you. So see, now we got the expression V is equal to 1 by 4 pi epsilon naught P cos theta divided by R square. So let us discuss about what are the special cases. So now special case 1. So special case 1, see, electric potential due to the dipole is maximum at axial line. So axial line means along the axis. So along the axis, so theta is equal to 0 or 180 degree. Okay, So what is cos 0 value? Cos 0 is 1. Okay. So if you substitute the here, so theta value, you will get 1 by 4 pi epsilon naught. So P divided by R square. Okay. So another case, special case 2. So electric potential is minimum if theta is equal to 90 degree. That is an equatorial point. On the equatorial point, electric potential of a dipole is minimum. Okay. So its value, so equatorial value is 0 and E axial. So E axial is maximum, that is V is equal to 1 by 4 pi epsilon naught P divided by R square. Okay. See, this axial line can also be taken as, so end on position. Okay. So this can also be said as end on position, and this one is, so by for the what is equatorial plane, it can be taken as broad on position. This is on end on position, this one is broad on position. Okay. So thank you.